Hey folks, I've been doing a lot of Rust lately and would like to write some graphical user interface apps. So I decided to take a look at some of the graphical user interface libraries available in the Rust ecosystem. And I have this chunk of time I'm going to dedicate it to take a look at ICE, just experiment, build something simple, check out the features and the syntax. And I thought, why not do it on camera as a YouTube video? Because you guys seem to like these videos where I just casually explore something and share my thoughts. So why not? Now, Iced is, from what I've heard so far, which is very little, I haven't done anything with it, is that it's Elm-inspired. The Elm architecture, if you're not aware, is a unidirectional data flow user interface architecture, similar to what Redux is, Flux, for example, where you have state that updates the view triggers some kind of actions, messages that update the state. And this unidirectional flow happens. That's how you build user interfaces. It's a nice architecture in general, one of the nicer attempts at managing the state of retained mode UI. So that's a good one. It can be built pretty well, and it's easy to test, etc. So that's a good thing. We'll see how they implemented it. The other thing that I know and caught my eye about Iced is that it's used by Cosmic. If you're not aware, if you're not in the Linux world, Cosmic is the new desktop environment that System 76 is developing that's written in Rust. And it's, I'm not sure what part of Cosmic uses Iced. I am guessing they're using it for the built-in applications. They should, if it's featured here, and that's quite nice. Maybe it's used more for than just for the apps. Maybe they use it for some of more of the core parts. I'm not sure about that. But it's great that Cosmic is here because this means at least some support, yeah, at least some indicator for future support, and that this library will be updated and maintained in the near future. Besides that, a few apps here. I'm gonna be honest, haven't used any of these so far. I haven't had the chance to check out Cosmic as well. As I was waiting a little bit, so that the alpha version would get updated, so that I can check something more stable, hopefully. And I think that's kind of already there. They are at Alpha 7, I think, which should be a lot more polished than the initial release. And I might check it out soon. I'm actually excited about that. Um, but I digress. Let's get started. My plan for this video is to build a simple app. They have this getting started guide, which I hope, yeah, we'll build some simple app. Check out the architecture, the syntax. I want to make sure, first of all, how they manage state. I want to explore that. Is it good? Is it elegant? Is it enjoyable to write? Second thing, how they render, how they actually render some kind of controls on the screen, and how they connect with the state. So events, management of events. And third thing, I want to see if I can compose an app into simpler items like components. Can we do components and compose them? I think these are the three pillars of modern UI. Sorry, these are the three pillars of a modern UI app, and in that order, I would rate a graphic user interface library nowadays. First of all, by how they manage state. Second of all, how they render. And third, how they compose into a larger app for complexity. And can you keep these atomic widgets, components, or whatever in a cleaner code base, and have a cleaner code base that's component based that you can maintain. So this is my plan. And here I see that they have this book or getting started guide. Let's check it out. Architecture. Yeah, they talk about graphical user interface, interactions, trigger, displays. That's basically the gist of it. They have this counter example, pretty classic. So we have the concept of widgets here. These are the components, widgets, whatever, in this case, button. I'm sure number or label or text or whatever. And I have interactions, actions, or however you want to call them, triggered by these widgets. and state. Okay. So yeah, as expected, this is a unidirectional full architecture, classic one. State renders view, view update state. Um, yeah, they talk about Elm, the model and everything. Messages, yeah, we have a different naming convention. State is clear. We have messages, actions, messages, and view. This is clean. I like that. Understandable and easy. We'll be building a counter here. That's fine. And starting with a struct, we have a state within it. And I really like that because we don't have anything custom here. This is basic language features in Rust. Let's in fact set up a project. I wanted to create a directory, but no, I will immediately create an Carbon iced test. Let's run it. Okay. And I'll run a tmux session. I'll open this in new vim and create another one so that I can run it right here in session 1 and edit code in session 0. And we have a hello world example. So I was going to say that I like that we start from a basic struct for state, not something custom like a state function or create state method. I like that. It hints at a minimal API, which is great. It's a good approach. I'll disable Copilot because we don't need auto completion. Now we're experimenting. Now we next talk about messages. And here we define an enum. These are basically the action types, the actions, the messages. An enum is of course not enough to implement the actions. These will just be used to determine which action we're using. I'm guessing we'll pass this into some sort of function as a parameter, an argument, and then we will check which message we're passing, and based on that, we'll act in some way. We'll see how. That's the interesting part. And that's exactly what the next part is. We handle updates by implementing an update function, logic in Rust, method named update in our application state. Okay. So we uh, basically associate the update function with the state. That I like that. That is very normal. And so we write update. It's very normal and makes perfect sense. And that update function gets self and the message. That's quite minimal. And here we have this match statement where we basically check which item from the enum is passed as message. And we have two arms. They have increments. And in case we increment, we'll of course increase the value by 1. We have message decrement. Here I'll check if self value is more than 0, then I will decrement it. And I'll change this to unsigned 32. I want my counter to stop at 0, basically. Is there something else we're missing? So yeah, that syntax is of course not enforced from what I can see. Ideally for simple apps, that's actually good. You get to a point with this architecture where the simplest approach usually is some kind of switch statement or match, in this case in Rust, to just map the action type to the actual code that executes an action or a state mutation. And that is fine usually, as state mutations are 1 to 5 lines of code. simple values for most components. On the other hand, here you can have anything. You get this update function where you get the message, and that is absolutely, you're absolutely free to implement anything here. Any dispatches and functional methods to associate this. But at the end of the day, you need to differentiate between the message type and the code you will execute. That you will have some of that somewhere. And this is the simplest approach. It's not bad at all. Okay, and after we build that, they talk about testing this sort of dry. Like so far, we haven't really done anything with ICE. This is basic language features. And of course, you can call update, create a counter, and output its value. And that's one of the good things about this framework that, yeah, they actually write a test here. You don't need the framework to test logic and state logic, state update logic. And that's a very big advantage of this framework, this architecture, that it's easy to test and very deterministic. Okay, now the interesting part, view logic. Actually, yeah, it's just the next part of it. How do we render? And here we start with iced. We import button from widget, which is just a function. I really like that, quite minimal. So let's use that widget button. Of course, we need to add iced. Okay. No more syntax highlighting errors. Where do we add that? Well, I'll do it in the main function for now because I don't know. Do you want to save this in variables? I'm guessing that's just temporarily because what's the point in saving them in named variables? We would need to pass them somewhere to render at some point. And ideally wrap them in some sort of layout, I'm guessing. But we have two buttons now. And we pass the inner text just as parameter. I'm guessing we can pass other things like children. Button. Yeah, content can be element, which element I'm guessing is some container item. Struct element, widget. Yeah, element seems to be every widget can fit there. Okay, let me just go back because I got lost. All right, let's just continue forward. Quite simple. Yeah. And now the number, text, okay. So far, consistent, but I guess that's expected because it's just text and button. Still, the API is quite minimal. So, text. Ironically, we pass an integer to it. Simply hardcode 15. Okay, so hardcoded for now. And they define an interface variable where they store this in a vector. Okay, that's interesting. I'm sure we won't need that. I mean, the variable at least. All of these variables, because we need to render this, and we don't need to store them anyway anywhere. Yeah, and here we change that vector to an actual column macro. It seems to wrap this in some kind of layout. Okay, let's do that. Cool. Creates a column and does so in order. Increment, counter, decrement. Okay. Interactions. Now that's interesting. On button, we just chain a function to it on press. That's nice. And we only pass the message type. So it would automatically trigger update. Okay, that's very minimal. All right. I like it so far. This isn't, of course, how that would usually look. You can just pass the scene line. In fact, let me do it. I still haven't got to the point where I render this, but I'm going to start refactoring. But it makes sense to have them like this. Then we can have the counter. Let me just write it. It's faster than moving. And button decrements. And this way, we can remove all of that and have only interface. And we can even return that somewhere and not have interface at all. But this way we can see it and it's structured like it will be visually. So it makes sense to have them like this and no point to waste memory on allocations and stuff. So here it says we need to derive the bookclone copy on message because when we pass it here, it needs to be clonable. That makes perfect sense. And it's not an issue at all. Message is very minimal. Yeah. And the view. So let's bring it all together into a view. How would that work? Aha. So we implement the view here in the okay, that's interesting. So the state holding struct implements update to update the state. And it also implements a view, which okay, I guess. Iced element message. Okay. Let me actually see. I mentioned I thought I disabled that, but I think I restarted new vim. Yeah, let's not return any type for now, as in the example. And we copy that exact item. And I'm guessing we return it like this. So yeah, I was going to comment that I'm absolutely for having update implemented for counter because this holds the state and update makes sense to be close to it and it acts on this value. Now, as for the view, I'm a little bit more torn on that. I don't know if you need to implement it for the same struct. This might very well, it depends how we render later, how we connect with ICE. This might be able to be a different structure, different function if you want. We'll check that out. But even so, even this way, it does make sense. As if you look at this as a single component, yeah, it does make sense. Now, let's check. How do we? Yeah, we just return column message here. I'm guessing that's my IntelliSense error, or maybe some of my refactoring broke it, but it shouldn't. Okay, it shouldn't. We just need to import column right here. Whoops. That should fix everything. Yeah, now we have just unused warnings. And that's the interesting part. How do we... I'm guessing that's enough to do everything, just render this application, this component, but now it's the interesting part. How do we render this? And wait. They offered the same refactoring. Yeah, it makes sense. It's simpler. And as I mentioned, it maps to the interface. Like you have a column layout, a button right here, then text value, and then another button. I actually forgot. I still have my hard-coded value here. I can change it to self value like this. Okay. And now runtime. How do we run it? Okay, some magical runtime. Great. I love magical runtimes. Um, Although very magical. Here they talk some basics about runtimes. Counter view, display. Yeah, that's obviously a simplification. Whooping. Aha. Domain whoop. Well, that's a little bit misleading, I think. I mean, I wouldn't say misleading, but um, we have a main application whoop interface. We display the interface. This renders. So we prepare widgets, render them, interact, handle messages, user interactions, and then for each message, update state. But that gives the impression that this is real-time application, sort of, where this happens like 60 frames per second. I don't know if it is. I am presuming it's retained mode, and that updates are triggered by state. Not that it doesn't have a main whoop, it's just retained at some point. So yeah, I mean, I'm guessing we might not need to write that at all. And yeah, we don't. We have a simple iced run function, and the main returns an iced result. Okay. I mean, can't get much simpler than that. This, I'm guessing, is the name for the window title and so on. And then we pass the update and the view. And that's great because, as you can see, we don't pass a single component. We just pass update and view. And it doesn't matter what they are. You don't even need to make a struct here. Although this is very efficient and I like it, you can go beyond that and build something entirely different. Your state could be a simple variable somewhere globally or whatever. Your functions can be just simple functions, for example. You can do a very different architecture. That's very flexible. I have an error. Yeah, I don't return the results. What other error do I have? Counter is the default, it's not satisfied. Oh yeah, here we don't initialize the default value, so we could derive default. This would make value 0, I guess. What is this warning? Unnecessary parentheses. Yeah, absolutely. C developer writing Rust. Happens all the time. Any other errors? Okay, that should run it, right? A cool little runtime. I think there's probably more options here, different ways to create. Like, if you think about it, at least you would want to configure a window, different widths, heights, whatever, title bar, custom title bar. This is probably a simplified way to run. And it's not bad that you have that. That might be enough for simple apps. And that, so far, the API is top notch. Like, so simple, yet very elegant and declarative. And this view almost looks like a markup language, yet it only uses internals, language internals that everyone knowing Rust knows. A basic function that's chained, an enum for messages, a struct for the state. Just amazing. I really like it. And this column macro is also good. Organizing layouts like this is awesome. The API is extremely minimal. I mean, I really like this. This is some of the best UI library code I've ever seen in terms of readability, ergonomics. But let's run it. I get carried away talking. Let's see what we get first. It's expected to take some time. For the seeing as what it is, the dependencies are not that many. This thing has a renderer, it has a windowing library. So that's fine. WGPU. I'm iced graphics. So I'm guessing from these names that they have a graphics renderer that can be used with different backends, and WGPU is one of them. That makes sense. That's how most of these libraries do it, and it's the best way. So, okay, so first impressions, here's the app. Now, notice I'll use the Windows magnifier. We do not have scaling, and this is a 4K display, so everything is very small. Now, that doesn't mean that ICE doesn't support scaling out of the box. It might, but this is WSL, Windows subsystem. This is Linux, the Ubuntu subsystem, and I'm running a graphical app through it because I'm developing like this. If I run this natively on Windows, it might detect the scaling and apply it out of the box. I don't know. What I do know is that currently everything is very small. The app seems to have created a native window and rendered something in it that's custom rendering with some kind of theme. We have these buttons. The state works. Decrement doesn't work. Increment does. Okay, why is that? Let's check it out. Probably something in my logic. I decrement by 0. Okay. There's never an app that's too simple to mess up. That's what you learn after a couple of years. All right. So, okay. I mean, this is nice. We have some defaults. Now, what I want to know is a couple of things. So far, we've learned that this library has a very elegant and minimal API. It utilizes Rust language features to the fullest and does not implement functions like create state, use state, or something like that. This is great. It offers flexibility in terms of state architecture to some extent. It enforces a certain data flow, which is expected and nice, but you are flexible as to how you manage everything within update, how you structure your update and view calls, which is great. What I want to learn now is, first of all, and this is obviously custom rendering, so can we theme this style different components? Can I create a custom widget? I should be able to. Can I render just custom shaders? Because graphical desktop apps usually need that in many cases. What kind of widgets are available by default? And let's start with some styling, I guess. Now we've reached the end of the book so far. It's not finished. We have a couple of options now. We can go to the API reference, the docs right here. I'm sure they will be helpful. Sorry, not magnifier. I want to just zoom the browser. And I will also use Qualt to help us. It should have knowledge of this. Although its knowledge might be a little bit outdated, but I'm sure it's fine. Okay, let's start by asking Qualt. I am writing an nice tab. How can I style my components? Let's say I want to change the text font size and color. So we chain functions and we have size color. Okay. It's talking about custom fonts. I know that we can render custom fonts. I'm not that interested in that. I wanted to see the style architecture in general. So we have properties here for these primitive types we can utilize. All right, that's fine. That's really fine. Let's do that. In fact, I'll use that to actually make this more readable. So let's say size 60. That should make this text readable on my 4K screen even without scaling. Of course, you shouldn't do that because the title bar and everything else would still be small. And for people that don't scale, this wouldn't work. So you need to support scaling somehow. I'm sure I support it. It's just because of WSL, but I don't know. Don't quote me on that. It needs to be tested natively to say for sure. So yeah, that worked. Let's try the color change. Color from RGB, right? Okay. So import iced color, and we can apply that. Pretty standard stuff. It's a little bit hard to read colors like this from 0 to 1 when you're used to 255 notations, but whatever. It's not that important. Yeah, we get a red number. Here's a question. Can I do something conditional here? Say, if self value is equal to 0, do that. Else, a different color, like 000. Or maybe red, green, blue. Okay, something like that. We have an error. Closing delimiter. Do we even need this? I think no. I shouldn't. And I also wrote, I think 3 triple equal, yeah. Is that still wrong? Mismatched delimiter and close delimiter. Where exactly? Let me see. Okay. I have a wrong. Okay. And here we have an error. So I don't need that. I'm used to ternaries, and that syntax sometimes confuses me a bit. What's wrong with that? Expected float found integer. Okay. There you go. You happy now? I'm guessing no. Okay. Let's test now. This took longer than I expected for a simple if expression. There we go. That's nice. So now, can we change the size of the text in the button? What if I say size 60? Will that work? No, there isn't size. Okay, button has a different API. But I remember we could pass an element in button. So I could pass a text here and have size on it, right? Okay, no IntelliSense error, so maybe I'm right. Let's check. It's usually a good indication that the library is good if you can guess the API. And yeah, it works. So what if let's apply this to the other one. In fact, I'll go to 100 so that it's visible in the video what we're doing. There we go. Great. Have 2 buttons. Not bad. I can't realistically check out memory usage now, this and CPU usage, because we're in development mode. This isn't a build app. Second, I'm running in WSL. I don't think I have graphics acceleration. Maybe I do. I I'm not sure. Maybe I have some. So it's not realistic to test it. If it was a native build app, we could. But I'm sure the performance is good. It's a custom rendered app. Uh, it should have great performance, actually. I don't know about memory usage. I expect it would use more memory than a standard immediate mode GUI like DRAM GUI app because it has the state management within it, but it should scale well in terms of with more complexity, more complicated UI. It should scale in terms of memory usage better than immediate mode. Theory. I don't know. So yeah, Cloud shows these methods. I'm not sure how. Let's check out styling. Okay. Um Here we have a lot. But yeah, we have these styling functions. I see that we have themes. The default theme of an application can be changed. Here we go, theme. That's great. So we have this concept of a global theme. And we apparently have a default theme. Let me check that out. Where's the themes module? Yeah, we have a couple of default themes. Um, it seems like theme is primarily a cowards thing here, because we have the standard Capuchin themes and Dracula, Groovebox, North, Tokyo, some interpretations of them, which is nice. It's nice that you have these. I'm sure you can also create, a custom theme to redefine colors. That's great. It's a good way to build that in so that people can start somewhere. What about, and here's how you run a team. Actually, let's do that. Let's check it out. I want to experiment a little bit. We use theme. We implement a function. Okay. So you can change it to runtime, of course, if you want to. And we pass to the application this callback, essentially. Okay. Is something wrong? Mm-hmm. So here we don't use iced run. Here we do iced application. We return an application and pass a new function to it. Okay. I want to see what that new function is. It probably is similar, just you can pass more options than just title. How that function work? Let me see. Is it implemented somewhere in here? Application. There we go. New function. Where is it? Come on. I should be able to. I mean, I want the application function. And theme sender to run. Functions. There we go. Default. What would that yield? I'm interested. Sorry, I wanted to just go to 0. This still is expected to take 1 argument, but it takes 0 arguments. Interesting. Um, Oh, okay. Understood. So this is the default state. Maybe required by bound. I'm a little bit confused by that. To be honest, I thought we return a nice result, and this does return a nice result. Here they return a new 64 default value. I thought this needs an entire new function that, and yeah, here we can set settings and stuff. But why do I need to even specify anything like that? Can I just specify 0 here then if it's state? It's not satisfied. We could ask quote, I guess, because the documentation is a little bit sparse. What is the first parameter of application? Mine is currently obviously wrong. I thought it's default state. That's the application state. Oh, it should be the default state. Ah, yeah, of course. Of course it should be counter default. That makes perfect sense. Yeah. I was thinking in terms of state because of their example, while the state of the app is actually the actual counter struct. So this error should probably be, oh, and state. Here we pass state to Tokyo, which should be a reference to counter. But even then, we don't really need it. Let's first run it without theme just to make sure it runs. And still counter. Wait, application title? Let me check. Seriously? So this isn't default state. Maybe it's old? I should have read. Maybe they changed it at some point, or I've misread the documentation. It's possible. It just confused me. So I still haven't wired up the theme, as I disabled it temporarily to make sure everything works. But yeah, this is the theme currently. Let me remove my cover logic so that we can see how it works. I will actually collapse this to single line, as there's no point in having multi-line for one chained method. And here we can just add theme callback. And theme can depend on state. That's crazy. So here we can, yeah, let's see. We can change the theme at runtime as we click the button, which is nice. And yeah, that's Tokyo. Okay. Let's see. If state equals 0, return that. At 1, or let's return another theme. Theme what? Mm, I need to check. Enum. Okay. Let's return Groovebox Dark. And in all other cases, let's just return Capuchin Mocha. That's my actual team right here in UVM. State value. Okay. Warning. Unnecessary parentheses. Yeah. Again, C developer in Rust. Struggles. Let's see again what happens. Now we should be able to dynamically change theme at runtime. Yeah. That's quite awesome. Very responsive. Yeah, it's a simple app, but still. Responsive and easy to write so far. Very much. Now, let's ask Quout for the documentation. Can I build usable custom widgets or components in ICE? I want to compose them in a larger, more complex app. So components are reusable stateful widgets that encapsulate their own logic. Sort of like something in like React. Yes. Component plus state. And here's how we make a counter component. Enum, message, pretty much the same thing. And then we implement new, update, view. That's quite simple. It's what we have really. We just go into to make it an element. And to use it, we just use the view and we map a message. Okay. Now notice we have two counters, for example, and we store them here. We have messages for both to handle the messages for both in a combined enum, and then the update function needs to match this and pass it. So yeah, this I was expecting this. You can compose this into components, but you need to manually manage the root component that will handle routing of action updates or something like. If you think of Redux, you need to manage the root reducer manually, so to say. If it's not a perfect analogy, by the way, but it is close. You need to manually write the code to route these messages and to handle the state composition. I was expecting them. I wasn't expecting them. I was thinking if they have a method to combine these, to aggregate them into a single item. Apparently not, at least from that answer. But even so, it's not that bad. You need to write some code to compose everything, but that's fine. I think that's fine, yeah. It's at least minimal and it gives you flexibility. Yeah, besides that, you have some simple functions. Yeah, so this is a stateless component basically. You just return an element with some styling and you turn it you turn it into an element apparently, and you can use it then. Okay, that's great. You can also build custom widgets by, yeah, that was expected. You can implement the widget trait. And that's more complex. Here you can draw. Okay, that's great. That answers my other question. You can draw. You get bound center viewport renderer. Awesome. So you have full flexibility to draw anything on the screen. Awesome. This is very good. I love this so far. What I would say is lacking, and I don't know how the other frameworks will be and the other libraries, but um, the guides are not great. The documentation seems okay. It's standard Rust documentation. You have the modules. You have actually. Let's test the documentation. What widgets are available? I want to check them out. Um, I'll go to the index, and from here, I would expect there to be widgets module because I saw it in widget. And here we have the modules for each individual widget. There seems to be quite a few, and macros. Yeah, for column we saw that, and structs. Okay, that's good. Now let's check out the widgets. We have some basics like button. I see some items for forms like combo box, text inputs, text edits, and some more interesting items. We have something called canvas, which is for rendering, but maybe simplified rendering like HTML canvas. You draw paths. Can be leveraged to draw interactive 2D graphics. Okay. We also have container, some layout elements, folds, grid. Okay. Image displays raster graphics. Can we display vector graphics? I'm sure we can, but the API, as you can see, is quite good. Image paths turns into an element. Quite good. Keyed. Here we go. That's interesting. For continuity, if you've worked with React, for example, you need to specify keys in some elements which you map. This is a similar problem. Continuity is tricky when you re-render constantly. So yeah, as I mentioned, continuity is tricky in the Elm architecture because the whole widget is rebuilt during every view call. And you can build dynamic user interfaces, but you need to keep track of what's changed for some widgets, like if you type in a box, for example. And that's where Keat comes in. I don't see how you use it. I'm guessing it's part of other widgets. And that's why there's no usage here, but it's okay. Now, this is unexpected. You can parse Markdown and display it. Or is it an editor? It's actually nice. We have the parse function and then a view, which can display it in a certain theme. That's quite good. I mean, these APIs are very elegant and minimal. Display elements on top of each other with overlay. We have pane grids of regions. Oh, nice. A video. Yeah, that's very useful. Something like Dear I'm GUI has this, and you can you can resize. I'm guessing you can drag drop. Yeah, that's very useful for desktop apps, especially more complicated ones with sidebars. I don't know if it supports docking zones. If it does, that's also very, very nice. But yeah, that's pretty good. And I'm guessing it has a more complicated. Wow, this is actually so simple. Wow. I really like that. Really, really like that. Hmm. Their API is made to be very minimal. I'll say that. Pick list is drop down. Seems like, yeah, it has what you expect. And in them, progress bar, yeah, these basic elements. QR code is interesting. I would not be expecting that in the core, but I'm guessing someone implemented it. Why not? Some roles and whatever for layout. We have a custom shader for WGPU applications. That's useful. You can write a shader. Yeah, that's great because you can render something. We saw you can render in a custom widget as well. That's nice. But that's a must in desktop apps. You need to be able to render whatever you want. We also have an SVG component for vector graphics. Again, simple, minimal API. I mean, I'm praising this a lot, but it's a very good API. And yeah, here they pretty much end. But this is a very solid core. Seeing as you can write anything, custom and extend these with styles and compositions, this is a solid core. And some macros, row stack, key column, pretty nice. Rich text. That's uh, that's what I expected in the best case from this, and I love it. It's great. It's great. I the documentation. We were on the part where I was saying that the documentation is okay. The getting started guides are not particularly okay because there isn't any. Just this one. This one is good, but it needs a lot more. Once that is finished, I think, yeah, I think once it has a better guide structure with more data in a finished book, this would be great for beginners and anyone really. So overall, I like it a lot. I would I'll make videos depending on how this is received. I want to also explore Egui because from what I can see, Egui is a very close equivalent to something like DRM GUI in that Rust environment, and I like it. I think it would be more lightweight than iced and simpler. It's also immediate mode, so it will be better for some applications. It can run on the web, as you can see. Of course, I'm guessing iced can too because it uses WGPU for rendering. You can use WebAssembly. This has also a lot of features at first glance, a lot of even more components. It's crazy actually. But I want to check it out as well. I don't know what the API will be. I don't think they will have anything for state management as their immediate mode. So state manages itself, so to speak. And that's actually nice for many applications nowadays. We might make a video about immediate versus retained mode user interfaces because that's also an interesting topic. And besides Egui, the other framework I want to check out is Slint because it's gaining a lot of traction. This, as I mentioned, this is basically Qt Quick for Rust, and it's not bad from what I can see initially. It has a similar markup language like not markup language, but declaration language like QML. It's a commercial project to a large extent. I don't know to what kind of large extent, but it's worth checking it out. So these are the three contenders I think I would check out in the Rust ecosystem. The iced is, man, it will be a lot to beat that. Um, I'm guessing Egui might beat it in terms of performance for small apps because it's immediate mode. It might consume less memory for smaller applications. Ah, but wow, in terms of API, if there's something better than this, I would be very surprised and pleasantly so. Yeah, with that, I think I'll wrap this video. I hope you enjoyed that and you found something useful. I really liked ICE. I would check the other frameworks out, but I would love to write an app in it and check out how that works because doing simple examples and testing stuff out is some very frequently enjoyable. Yet when you get to build something and you reach some constraints, sometimes frameworks and libraries can fall apart because of lack of flexibility. This doesn't seem like that. It seems to be very minimal and letting you do everything that you want, from managing state however you want, as long as it fits the Elm model, to rendering whatever you want in the window. So it's quite powerful at first glance. And as I mentioned, the API is so solid. I will wrap this up. Uh, don't forget to subscribe to get notified when I release another one of these videos. Take care.